Okay, guys, here is the 7.3 part 1. We already did part 2, which was the partial fraction decomposition. And this section, part 1, is another way for you guys to solve equations. You've used the systems of equations by solving using the elementary row operations. That was when we did like -3 times row 1 plus row 2 and all that. We solved using Kramer's rule, finding the determinants of all of that. And now we're going to solve using what's called Gaussian elimination. You guys are familiar with, we already talked about this, I'm going to go through this quickly, but you're familiar with when we have three equations, they're all linear, everything's to the first power, and you have an x and a y and a z. So your answer is going to be what's called an ordered triple. There's an x value, a y, and a z. When you have your equation set up in this form, this is called row echelon form, you can use back substitution to solve. So you would just take the z value, plug it in here, find out what y is. Then you would take both of those, plug them into this equation, and find out what x is. So you guys know how to do that. If you're asked to test if something is a solution, I want you to really, really pay attention to this, guys. If they give you an ordered triple, or you solve and you get an ordered triple, you need to make sure that you plug in the x value into every single equation, the y and the z, in all three equations, and that they are all true. Sometimes you'll solve an equation and it'll work in 2 out of the 3 or something, so that means you made a mistake. But if they're asking if something is a solution, you have to plug into all 3 equations, and it has to make all 3 equations true. So what we're going to learn today is another way to solve systems of equations that have multi-variables. So we're going to have an x and a y and a z. Ms. Chris Weiser so beautifully typed this up. If you guys want to follow these directions, you're more than welcome to. This is going to kind of be what I follow, and this is what I'm going to refer to. So I want you guys to understand what this says. What you're going to do is you want to make sure the first equation that you use begins with a positive 1x. If it doesn't, figure out a way to make it. Either move it to the top, and this will all make more sense when I do this, but move it to the top, divide everything by a negative, factor out the GCF, whatever, but that's going to be your first equation. And you're going to want it to be set up with an x, a y, and a z equals to a number. Then to get your second equation, you're going to combine equations 1 and 2 and eliminate x. Then that'll be your second. You'll have an x, a y, and a z and a number. Then you have to do 2 steps to get the third equation. You're going to first combine equation 1 and 2 from the original, eliminate the x. Then you're going to combine the 2 equations that just have a y and a z to get rid of the y and to get z by itself. I know that sounds kind of confusing and a little bit like, what? But I promise you it's not that bad. We're going to do 4 examples right now, and then you have some homework problems to practice. Your homework's going to be due on Monday. If you're in class tomorrow, you're welcome to work on it in class and ask me questions and that sort of a thing. But you do need to answer in WebAssign, showing all your work and attaching your WebAssign score. So what our answers are going to look like, you're going to get into row echelon form. And then from this point, we're going to use our back substitution, T-I-O-N, and then take your z value, plug it in here, and get y, and then plug in the y and z and get x. Let's go through some examples here, okay? I'm going to start off like this. I have 3 equations, 3 variables. We want to get it into row echelon form. So my first step is to say, okay, I want my first equation to start off with a positive 1x. It does, so I'm just going to rewrite that equation. So I have x minus 2y plus 3z equals 9. I want my second equation to just have a y and a z. So according to the steps I just wrote in the previous slide, we're going to take equations 1 and 2, and we're going to combine them. We're going to eliminate the x. So x minus 2y plus 3z equals 9. Negative x plus 3y plus z equals negative 2. So in order for equations, when you combine them, for the variables to cancel out, they have to be exact opposites of each other. In this case, these already are. I don't have to do anything to these 2 equations. I have a positive 1x and a negative 1x. So when I combine, these cancel out. Negative 2y plus y gives me, or negative 2y plus 3y gives me y. 3z plus 1z gives me positive 4z. And then 9 minus 2 equals 7. So there you have created, guys, your second equation. I'm going to write it over here as y plus 4z equals 7. Now, if you go back to my last slide, I said to get the third equation, now we have a two-step process. The first thing we have to do is we're going to combine equations 1 and 3 and eliminate the x. So x, just be careful when you rewrite, x minus 2y plus 3z equals 9. 2x minus 5y plus 5z equals 17. Now, if I want my x's to cancel out, I have a positive x and a positive 2x. So I'm going to say, all right, I'm going to go ahead and multiply my top equation by negative 2, and then I'll get my x's to cancel out. When I distribute this negative 2, this becomes negative 2x, negative 2 and negative 2 becomes positive 4y. Negative 2 and 3 becomes minus 6z, and negative 2 and 9 becomes negative 18. So now this isn't there anymore, and then when I combine, my x's cancel. Negative 5y plus 4y is just negative y, and then I have 5 minus 6 gives me negative z equals negative 1. So now again, if you refer to my last slide, it said the first step to find equation number 3 was to take 1 and 3 and eliminate x. Now we have two equations left over that have a y and a z. We're going to combine those two to eliminate our y's. So I'm just going to take this blue one and write it over here. So I'm going to write it underneath, say y plus 4z equals 7. And when I combine them, these cancel. Negative z plus 4z is 3z equals negative 1 and 7 is 6. Divide both sides by 3, and z equals 2. So we have now created our row echelon form of our equations. These two equations are the exact same amount, same value, they're the same things. You've just converted them from one form to another. Now, in order to solve, to make sure that we know that we did this right, and now we got our ordered triple, we're going to use our back substitution. So I'm going to take z and plug it into the blue. So y plus 4 times 2 equals 7. Y plus 8 equals 7. Subtract 8 from both sides. And y equals negative 1. Now I'm going to take y and z and plug it into my top pink equation and find out what x equals. So x minus 2 times negative 1 plus 3 times 2 equals 9. X plus 2 plus 6 equals 9. X plus 8 equals 9. So x equals 1. And now you guys have your answer, your ordered triple. My x value is 1. My y value is negative 1. And my z value is 2. So you could now take these three, plug them into each equation here, and make sure that they make all three true. So on your quiz, I'm going to give you guys one where you have to do back substitution, which is what we just did here. And then 1 or 2, we'll see, where you're just going from this form here of our three equations, three variables, to the row echelon form to then solve to our ordered triple, which is the exact same thing you guys have done with Kramer's rule, with the row elementary operations. It's just a new way to do it. All right, so to the next question. All right, let's think about what we need. We need our first equation to be a positive 1x. Well, it's not a positive 1x. I could divide everything by 2, but then I'm dealing with fractions. That's kind of gross. But I do notice that equation number 2 starts off with a positive 1x. So all I'm going to do, guys, is just move it up here. So my first equation, I'm going to start off, I'm going to rewrite and say my first equation is x minus 2y plus z equals 8. And then now we can go on. What do I do first after I get that? I'm going to take equation 1 and 2, and I want them to cancel out the x's. So I'm going to take my x minus 2y plus z equals 8. I moved the other equation down here. So this becomes 2x plus y plus 3z equals 9. Now, if I want my x's to cancel out, I need my top equation to have a negative 2x. So let's just multiply everything by 2x. Negative, sorry, I should say. So negative 2x negative 2, and negative 2 is plus 4y. Negative minus 2z equals negative 16. So this is no longer there. So my x's cancel. I have 1y and 4y is 5y plus z equals negative 7. So there is my second equation. 5y plus z equals negative 7. And then I have my two-step process. I need to eliminate x, and then I'm going to eliminate y. So I'm going to take equation number 1, x minus 2y plus z equals 8. And I'm going to combine it with equation number 3, negative 4x plus 3y plus 2z equals negative 4. Now, if I want my x's to cancel out, you guys should be able to see I need to multiply the top equation by positive 4. So 4x minus 8y plus 4z equals 32. So this is no longer there. Now when we combine our x's, these cancel. 3 minus 8 is going to give me negative 5y plus 6z equals, this is going to be 28. Okay, so step 1 is done there. I eliminated my x's. Now I'm going to take my two leftovers right here. I have leftover here, leftover here. I'm going to combine those two and get rid of the y's. Does not matter where you write what. I can write this one here and this one underneath. It doesn't matter which one goes first, which one goes second. It'll work out. So when I combine, I don't have to do anything, guys. My y's are already exact opposites of each other. So these will cancel. 1z plus 6z is 7z equals negative 7 and 28 is 21. Divide both sides by 7, and z equals 3. So there's my final equation, z equals 3. So there's my row echelon form, which is exactly what we wanted. We wanted first equation to have 3 variables, second equation has 2, last equation has 1. Now, guys, you guys might work it out where you do it in different orders and get different equations. But you should always get the same ordered triple when you use your back substitution. That means you did your problem right. So when I use back substitution here, I have 5y plus 3 equals negative 7. We're going to subtract 3 from both sides. 5y equals negative 10. So y equals negative 2. And then I'm going to go and substitute into the top equation to find out x. So x minus 2 times negative 2 plus 3 equals 8. Well, x plus 4 plus 3 equals 8. X plus 7 equals 8. So what does x equal? X equals 1. So your ordered triple, the solution to this problem is going to be 1, comma, negative 2, comma 3. And again, you can take this, plug into all 3 equations, and it will make them all true. So all of this work to support how you got your equations in row echelon form to then finding your ordered triple is the answer to a question like this. I know it's a lot, but you know, there's a lot to do with Kramer's rule and the elementary row operations as well. So, okay, let's do another one. Two more, and then you guys are ready to practice on your own. So I look, what do I want first? I want my first equation to have a positive 1x. I absolutely have that, so I don't have to do anything to that. I can just rewrite my first equation. X plus y plus 3z equals 7. So now I'm going to take equations 1 and 2 and eliminate my x's. So x plus y plus 3z equals 7. And then I have 2x minus 4y plus z equals 7. Now I want my x's to cancel out, so I need my top equation to be multiplied by negative 2. So negative 2 times x. Negative 2x minus 2y minus 6z equals negative 14. So this is gone, and then when we combine, my x's cancel, so I have negative 6y minus 5z equals negative 7. All right, cool. So now I need to do the same thing after I got to rewrite this. This is what we were looking for. This is our second equation. Negative 6y minus 5z equals negative 7. Now I take equations 1 and 3. I'm going to eliminate x's. X plus y plus 3z equals 7. 3x plus 5y minus 4z equals negative 6. If I want my x's to cancel out here, guys, I'm going to need to multiply the top and bottom by a negative 3. So I have negative 3x minus 3y minus 9z equals negative 21. So this is gone. My x's cancel. 5y minus 3y is 2y minus 13z equals negative 27. I know some of you are like, oh, that doesn't seem like it's right. Those numbers are kind of weird. Don't freak out. Wait till the end when you get something really odd for z equals to say, wait a second. All right, so my last equation needs to say just z by itself. So I'm going to take my two leftovers here, and I'm going to combine them. I'm going to rewrite here. I have negative 6y minus 5z equals negative 7. And here I have 2y minus 13z equals negative 27. I want to cancel out my y, so what am I going to have to multiply? Well, let's multiply my bottom equation by 3. Because if I do that, then my y's will be opposite. So I have 6y, 3 times negative 39z equals negative 81. So this is no longer there. And now I can combine my y's. So the y's will cancel. Negative 5 and negative 39 is going to give me negative 44z equals negative 7 and negative 81 is going to give me negative 88. Well, look at this, guys. When you divide both sides by negative 44, you get z equals 2. Nice and pretty. So z equals 2. So when we do our back substitution, let's plug it in and see what happens. So if z equals 2, I'm going to say, okay, well, negative 6y minus 5 times 2 equals negative 7. Negative 6y minus 10 equals negative 7. Negative 6y equals, and I add 10 to both sides to get 3. Divide both sides by negative 6, and you get y equals negative 1/2. Is that all right? Are we allowed to have fractions? Yes. Fractions are like fish. They are our friends. So then let's look at finding out what x equals. So I have x plus, or we could say minus, x minus, I was going to say plus and negative, but x minus 1/2 plus 3 times 2 equals 7. I'm going to say, okay, x minus 1/2, I have plus 6 equals 7. I'm going to go ahead and change everything into seconds, just so it's a little easier to look at. So x minus 1/2 plus, well, 6 over 1 is the same as 12 over 2. And 7 over 1 is the same as 14 over 2. So when I combine right here, I have x plus 11 over 2 equals 14 over 2. And then when I subtract 11 over 2 from both sides, x equals 14 minus 11 is 3 over 2. So my ordered triple in this case happens to have fractions in it, no big deal. It's 3 over 2, comma, negative 1/2, comma, 2. Fractions are possible. You're just not going to get those crazy fractions if you get, negative 178 over 43 or something like that. It'll be something very manageable, like 1/2, 1/5, 2/7, something like that where you guys can handle it. All right, lastly, let's look at one more. And then on Monday, before our quiz on Tuesday, because we have a quiz on this on Tuesday, Monday I will go over your web assigned questions and work through some problems, just make sure we're all understanding what's going on here. So first thing I do, I need my first equation to be a positive 1x. I have two equations that are positive 1, so you can pick whichever one you want. I'm going to go with the one that's already there. I'm going to keep the first one where it is. So x minus 3y plus z equals 1. So now I'm going to take equations 1 and 2, combine them, and get rid of my x's. So x minus 3y plus z equals 1, and 2x minus y minus 2z equals 2. So if I want my x's to cancel out, I'm going to multiply the top by negative 2. So negative 2x plus 6y minus 2z equals negative 2. So this is gone. And when I combine, my x's cancel. Negative y plus 6y is 5y. Negative 2 and negative 2 is negative 4z equals 2 minus 2 is 0. So there's my second equation. 5y minus 4z equals 0. Okay, perfect. Now I'm going to come over here and I'm going to say, all right, let's figure out how to find that last equation. So I have a two-step process. I need to first take 1 and 3 and eliminate x's. So x minus 3y plus z equals 1. X plus 2y minus 3z equals negative 1. Well, I notice now, guys, I have 1x for both of them, so I just need to multiply one of my equations by a negative 1. I'm just going to multiply the top one by negative 1. So when I multiply by negative 1, that's going to change all of the signs. So this becomes plus, this becomes a minus, and this becomes a minus. So when I combine my x's, I have, excuse me, 3y and 2y is 5y. Negative z and 3z is minus 4z equals negative 1 and negative 1 is negative 2. So now I look and I say, okay, well, I have two leftovers. Those two leftovers both have an x and a y, so I'm going to combine these two together. So you can rewrite them, or you can just write one on top of the other. It doesn't matter. And then I have 5y minus 4z equals negative 2. So if I want my y's to cancel out, again, I need to multiply something by a negative. So I'm just going to multiply the whole bottom by negative 1. So this becomes negative, this becomes positive, and this becomes positive. So my y's cancel out, perfect. My z's cancel out, perfect. And then I have 0 plus 2 is 0. Guys, is it a true statement that 0 equals 2? No, that is not true. So when you have that happen, when you get your variables to cross out, you get 0 equals a number, that is telling you that there is no solution. Very similar to how if you're solving using Kramer's and you get the determinant value to be 0, then you'd have to divide by 0, it'd be no solution. So in this case, there is no solution to this system of equations. If you got it to where everything canceled out, it was like this, then it would be infinitely many. So there's either no solution when you get an untrue statement, or when everything cancels out, it's infinite many. Or you'll just solve it to where you get your row echelon and it's z equals, then plug back in and your back substitution. So tomorrow in class, if you're in class, you're going to have the class period to work on the web assign, ask me questions, that sort of a thing. And then Monday, we'll go over all of these problems, get you ready for a quick little quiz on Tuesday. And then seniors, we're going to start reviewing for your finals.